Okay, Unit 11 of Algebra 1 was all about exponential functions. So let's really quickly review the parts of an exponential function. This red dotted line down here represents the asymptote. And remember that an asymptote is just the imaginary line that it does not cross or touch. So for our class, it's almost always going to be y equals 0, okay? That's because we're not going to learn about transformations of exponential functions. You'll do that in Algebra 2. But we do know that this is a horizontal line. It's a HOI, so the equation will always be y equals 0. Then we also talked about the y-intercept. It's just like any other y-intercept from throughout the year. It's just where the graph crosses the y-axis. Okay, those are really the only two pieces that you need to know about an exponential function. So let's talk about the equation. Y equals ab to the x, or a times b to the x. Remember that the a represents the y-intercept. That's why that point is important, because it's a part of your equation. And then the b represents the rate at which those values are changing. Okay, and we've also, just kind of to put it in more layman's terms, it's the number you're multiplying by. When you think about a geometric sequence, it's the common ratio, that number you multiply by over and over. So let's write an equation really fast for this table and graph. They are the same, but I'm going to show you how on either one you can write the equation. So looking at the graph first, again, I know I need my y-intercept, which I see right here is 3. So I'm going to write y equals 3. And then I need to know how these numbers are changing. Well, the next point is a 6, and then the next point is a 12. I can tell that to go from 3 to 6, and 6 to 12, I need to multiply by 2. So there's my equation, 3 times 2 to the x. You can see this in the table as well. Again, here's my y-intercept because it says 0, 3, so y equals 3. And then these values are doubling as you look along the bottom of the table, so 2 to the x. Okay? Now, the only exception to writing an equation that way is when you're given a percentage. Sorry, my iPad is a little wonky right now. So these are the two formulas that we learned for when you're given a percentage. So if a story talks about how you've got bunnies and their population is increasing at a rate of 12%, right? Well, you would need to take that 12% and change it into a decimal. So you'd move that decimal 2 times to the left and you'd have 0.12, right? 12 hundredths. And you'd plug that in for the R, okay? You choose your formula based off of whether or not the situation is growing or increasing, or if it's decreasing or decaying, okay? So when you end up working out these formulas, you'll end up with a B value, because the A is still there. It's just that this B value has been broken down into 1 plus R. If it's growing, your B is going to be greater than 1. So in this case, it'd be like 1.12. That is bigger than 1, right? Or if it's decaying, it's going to be a number in between 0 and 1. So again, if it was 12%, you would end up with 0.88. So this is the same as the problems above because 2 is greater than 1, so it is increasing. It just so happens that when you have a percentage, you just have to work a little bit harder to figure out what that formula should say. So here's some star questions. I just threw them all in one page just to talk about them very briefly. Scientists are studying a bacteria sample. Here's the equation that they give you. They want to know which one best interprets that function. The initial number is 12. Well, no, that doesn't work because our initial number is 245. It decreases at a rate of 88%. Well, if that was true, then we would be doing 1 minus 0.88. And that is not going to give me 1.12. The number of bacteria increases at a rate of 12%. Well, that'd be 1 plus 0.2, or 1.12, sorry. And that does seem to work. So I'm thinking the answer is H. And then J, the number of bacteria at the end of one day is 245. Well, that doesn't make sense because we're starting with 245. So the answer there has to be H. Okay, which statement about this equation is true? The coordinates of the x-intercept are, stopping right there, it's not going to have an x-intercept because it doesn't cross the x-axis. The y-intercept are 0, 8. That sounds pretty good because this 8 does represent my y-intercept. The asymptote is x equals 0. That's not true because it's supposed to be y equals 0. It's a HOI that we're looking for. And then the graph includes the point 2, 1. You can either plug in this point, right? 1 is the y, and 2 is the exponent, and test it out, or you could put it in your calculator and look at the graph. Either way, J is not my answer. G is what we're looking for there. The last star question I'm going to show you is where you're matching some graphs to the equation. And again, you just want to think about what these numbers mean. The 2 should be the y-intercept, right? So looking at my different graphs, the one that I could eliminate for sure would be H, because it's at 10 here, so that's wrong. J is at 5, so that's wrong. Both F and G, it's hard to tell, but they could both be at 2, so I'm not going to eliminate either of those. But then the next number here is 5. That's how it's increasing. Well, if I take 1, for example, as my x, and I plug it in, that's going to be 2 times 5 to the 1. Well, that really just means 2 times 5, which is 10. So when I plug in a 1, I'm going to get a 10. So that's a coordinate now that I've just figured out, 1, 10. So this has a coordinate at 1, 10. This has a coordinate at 1, 5. So my answer here has to be